Alright, so we're going to kind of look at Chapter 2 to start things off, and then go from there. So some of this is going to look familiar, but we'll kind of go through it again in case it's been a while since you've seen it. So Object 2 jumps into the object-oriented programming part of Java and computer science, and so we're going to look at these pieces are objects, attributes, methods, and again, some of this should be review as we've looked at Carol already. So an object is just a representation, so we have this class file that we have, and it represents the kind of general piece of an object, and it tells us the services that it can do for us. We call that the methods, right? It also has the data attached to it. And then the methods are in this class, so we have a class of object, and then that's our general piece that we go from there. So we've seen stuff like this before. We have the ability to do things, those are the methods or behavior, and they can remember things, those are the instance variables or the state. So we, in general, say an object has state and behavior. The class, a couple ways to think about it. You have a blueprint, you have a cookie cutter. Again, you've seen this before, but the class would be the actual cookie cutter, and then when you make an instance of that cookie, that's your object. And so to be able to make that object, you would need a constructor, and a constructor would tell you how you would use that heart class to make that object. And that's kind of the basics of what we do. So we have our parameters and we know what we do with those pieces. And again, this is relevant because it's how the world works, right? We have objects that are in different classes. We inherit things through our from our kingdoms, and then eventually you get a species, which is a general class of object, right? In our Java notation, it would look like this, where we have our object declaration. So we have our panther. So this is the object type, right? This is the name. We're making a new class of that, and this is the constructor, right? So our constructor, and it takes two parameters, right? A panther mom and a panther dad. And the beauty of object-oriented programming is we can encapsulate that data. We don't have to know the details behind how that works, but we can use it and use code that other people have written. So again, there's our class, our object, that's our constructor. So in general, we could have stuff like this. We'd have a bank account class. We could have types of bank accounts. So this would be the idea of our inheritance diagram. So these build or extend, right, on account, and then we'd have actual extensions on those classes as well. And remember, these attributes carry through. So anything that an account can do, a bank account can do, and a checking account can do. Anything that a bank account can do, a checking account can do, as well as whatever methods or data checking accounts have. So like write a check, right? If that was a method, that would be specific to bank account. That would not, right, would not carry back up to our other classes. All right. And so Chapter 2 deals a lot with our print statements. And so let's look at those for a minute. We have an object here. We have the system class. So this is a class. This is an object, an actual instance variable attached to a system class, and that's a method attached to that object. And then this thing in here, this is actually an object too, and this is what's called a string literal. And what it is, we don't have to use a new command. So it doesn't look like this, string str equals new string, and then in there you'd have the quote. We don't have to do that for strings because they happen so often, so it'd be such a pain if we had to do that. We have this thing called a string literal, which is an object. We actually just don't have a reference variable attached, so we don't know where this is in memory. It's been created, but we lose it when it's done. So this is an idea of a string literal as we kind of move forward. Alright, so we have a print method. This piece will print things in a straight line. So print will, if you have a print piece, will just continue across the line. Print line will make everything go to the next line. So we can use a combination of those two to have statements show up on the console. This is not the same as printing something to a file, but it allows us to visually see what's happening in our program. So we use it a bunch. So we have here a couple of print statements. So we can say, right, that in this case, these are print. This is all on the same line, right? So it just carries through. And then these print line statements are like a return statement. So those are going to make it return to the following line. So if we were to look at that output, we would have something that looks like this. 3, 2, 1, liftoff. After that last after this piece, the thing that shows up on the next one is the Houston one. If we had something after this, system.out, blah, 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 print, it would show up on the next line too because of this print line piece there. So we have to pay attention to print versus print line, and you'll use both to get the kind of console output that you want. All right. Abstraction is a really big computer science term. And so it's basically this kind of a modeling of our pieces. So we want to think about kind of what the methods do and what an object does without having to worry about the how behind it. So the easiest one is we don't know how the print line method is actually working, but we just have to know how to use it. And we know that it takes a string, right? We can pass it a string literal and it will be able to use that. So we want to not have to worry about all the details. Instead, we want to be able to build on previous programs, and that's where this idea of abstraction really helps us with our programming. Just to kind of show you what this looks like so we can pick it apart a little bit and recognize the pieces, right? This picture piece, this is a class, I know, because it starts with a capital. This is the name of the object, right? And this deals with the constructor. And I can see that it takes 2 parameters, and those are ints. So I'd expect that constructor to have 2 parameters and the ints. This is another class with another piece, and then these are the methods, right, for that object. So we know that it has a constructor that takes 2 parameters, and then we have the ability to use these methods: set, pen color, turn, forward, right? And we want to make sure that on our paper, right, that has the ability to show. So again, we start to pick these things apart and see how they're embedded as we go forward with this. I'm going to skip this for now. This is a dependency diagram in code, but we can talk down the road about it. This is your BlueJ template. So again, as we start creating objects, you'll become much more familiar with this. But in general, right, we have a class declaration, a definition. This is the constructor, has to be the same name. All right, and you can see here there's actually no return type. So it's not void. There's no int, there's no object that comes back. Everything else will have to have a specified return type. So this is a special method name. You can have something, you can have an overloaded constructor and put different parameters if you want, but for the most part, unless we have instance variables at the top here, there's different ways, different situations where you design it differently, but the key part is that your object would have that same constructor name. This would be an example of a runner. We can tell why, right? Again, just like in Carol, we have a main method. This is where we have the object's creation. So this is my object is actually built here. This is the instance. So going back to the first one, this is where the cookie is made. The other piece is where we've decided how you actually make that cookie. So you go to that my class piece, you look at the constructor, and you'd see what to do with those components. And again, this is the UML diagram that you've seen a ton in BlueJ, but just shows you that hierarchy going through. All right, so this is, again, we're going to focus a little bit more on strings here, and we'll get into some escape sequences. But the big idea is a string is a class, which means it's an object, which means it has method, and which it has data as well. So we can use those pieces to kind of parse strings together. So if we look at here, the first one that we want to kind of see here is we have the ability to add strings. So this, when we add them, is called concatenate. I think, strings. It just means bring them together. So you take these 2 pieces and you would add them together. It's not the same as a number. You just take those 2 strings as strings of characters and you put them together. You can have digits within a string. What's interesting is if you take a string, this is an int, and this is a string literal, and it will combine this. It will turn this into a string and concatenate. So you have the ability to have that output. And if you embed it in the middle too, it will take that 40 and turn it into a string and then deal with it and concatenate with the two other pieces that are on the sides of it. So your output would end up looking something like this. And so you can see that that looks like a nice formatted print statement and seems pretty simple. Now you get a little bit into trouble if we take ints and start concatenating them with other pieces, and we'll look at that here in a second. And so if we see what happens here, what the compiler of the program is doing is it's going to concatenate that with a string, right? And then it's going to see that as a string, and so what's going to happen is these are going to get added as strings, which just get slammed together and you get 2, 4, 4, 5, which is not correct. But if we put in our order of operations, we want to add these as ints, right? And then concatenate with the piece and actually get a numerically correct response. So be careful as you start embedding these in here that you really have the value that you want and that you're not concatenating strings, you're looking at the value portion of your number. Alright, this is not a huge topic on the AP exam, but can be helpful for stuff like formatting text. So we have what are called escape sequences, which means if you build them if we build them into a string, it will actually exit the string and give us those values. So the ones we use a bunch are tab, so that will start to format our pieces. New line is probably the most. The other ones, we don't do a ton of this. This would be more if you're doing like a file name. Or you needed like to write the word like http:// you had to put those pieces in there, and you didn't want it to be an escape sequence. You'd have the ability to do that or do a file path. But I'll show you what those look like and kind of how they would work. So in general, we have, this was like your poem piece, right? So this here, that N, that's a new line. This is going to tab things over, right? There's another new line, there's another new line in tab, right? Then we have our quotes, and then we have another new line in tab, and then we have, I think, one more there. All right? So if we have those escape sequences built in, we have formatted output that would give us something that looks like that. And you can see where those are, right? So we have the new line in the tab after red come to this. So we get the next line and we get that tab, that space over, which will give us kind of a formatted output if we want. That's not as big of a deal anymore. That, you know, it used to be back in the 80s or even early 90s if you wanted to print, you wrote to a file and you wanted to print that file with some formatting, you'd be more worried about this. But it's not a huge topic, but we should know it for what it is and that it does exist and come up and can be useful. When you need to use it, it really does help. Alright, we've talked already about variables, and the big piece is that it's a location in memory. We need to declare the type, we need to declare the variable name, and we can also declare multiple types at one time. So that is our piece that looks like this, where I can say I need multiple ints, right? I don't have to necessarily do that with multiple lines. I can put them all in one line. We can declare and give it a value at the same time. That's not too bad. And then we can use it. And so once we have that variable stored, we have this declaration of int keys. It's assigned a value of 88, and then we can throw it in to a print statement and use it to make things a little bit cleaner as we kind of move forward here. And that would be our output. Alright, we have our assignment, and again I'm going to go through this a little bit quickly because it should be relatively straightforward. We also have the ability to write a constant. I talked a little bit about this before with our notation of all caps. If we put final on front of it, it cannot be changed. Cannot change. Alright, this piece here is convention, which means if I see something in code where I have all caps, I'm going to think that that's a constant. However, that doesn't enforce it. The enforcing part is the final piece. So we have the ability to declare something as a final, and that would then stick. There'd be no way to modify that down the road. And again, there's different ways we do it. A lot of in science class, you'd have some final value that you'd want to set. Alright, so the opposite, well not opposite, but the other alternative to an object is primitive data.